Hello dear students, welcome to the lecture 9 of Object-Oriented Programming with C# course. So today we are going to see abstract modifier, dynamic polymorphism, multi-level inheritance and such. Let's start with composing a new project as usual. Let's pick our repository, folders. By the way, I will show you examples about our crawler in the following lectures. Don't worry about that. However, you can also already start working on it. It is fine. Okay, so let's start with abstract modifier. Okay. One moment. Okay.
C# abstract classes.
Okay, computer is having hard time to compose the project. Okay, project is still getting built. Let's read the abstract classes.
Abstraction in C# is the process to hide the internal details and showing only the functionality. The abstract modifier indicates the incomplete implementation. The keyword abstract is used before the class or method to declare the class or method as abstract. Also, the abstract modifier can be used with indexers, events and properties.
Alright, so this is similar to the English definition of abstract word. So here we just indicate a class or a method is abstract and has no body.
Abstract method, a method which is declared abstract, has no body, and declared inside the abstract class only.
Okay, so when we use abstract,
Generally, we use abstract class at the time of inheritance. A user must use the override keyword before the method which is declared as abstract in child class. The abstract class is used to inherit in the child class. An abstract class cannot be inherited by structures. It can contain constructors or destructors. It can implement functions with non-abstract methods. It cannot support multiple inheritance. It can't be static.
okay, so let's follow the example of here. All right. So we define the abstract class with abstract keyword in front of the class and abstract keyword in front of the return type of a method. So this is the method definition and this is the class definition. And then there is another child class of the abstract class here. Okay, you see. So the child class inherits the geek or geeks class here, which was abstract class, and we use override keyword to override the abstract method, and we write console write line. I will make this as message box show like this. So we have overridden the abstract method, and there is another child class, inherited class from geeks for geeks. And this also overrides the geeks for geeks. Yeah, it is same. And okay. I think that wasn't a good example. Maybe this one is better. Okay, let's read more about the abstract classes.
Following are some important observations about abstract classes in C# 1. An abstract class does not mean that it only contains abstract methods. An abstract class can also contain non-abstract methods also.
Okay. I still didn't understand why we should use the abstract class. Maybe you also didn't. So let's check for a better explanation.
When designing applications, it is important to know when to use an abstract class and when to use an interface. Although abstract classes and interfaces seem similar in some ways, there are key differences that will determine which is the best choice for what you're trying to accomplish. In this blog post, I'll discuss those differences and how to decide when to use which. The short answer: an abstract class allows you to create functionality that subclasses can implement or override. An interface only allows you to define functionality, not implement it. And whereas a class can extend only one abstract class, it can take advantage of multiple interfaces.
Okay. And whereas a class can extend only one abstract class, it can take advantage of multiple interfaces. Okay, let's read more.
C# abstract class explained. An abstract class is a special type of class that cannot be instantiated. An abstract class is designed to be inherited by subclasses that either implement or override its methods. In other words, abstract classes are either partially implemented or not implemented at all. You can have functionality in your abstract class. The methods in an abstract class can be both abstract and concrete. An abstract class can have constructors. This is one major difference between an abstract class and an interface. You can take advantage of abstract classes to design components and specify some level of common functionality that must be implemented by derived classes. C# interface explained. An interface is basically a contract. It doesn't have any implementation. An interface can contain only method declarations. It cannot contain method definitions. Nor can you have any member data in an interface. Whereas an abstract class may contain method definitions, fields, and constructors, an interface may only have declarations of events, methods, and properties. Methods declared in an interface must be implemented by the classes that implement the interface. Note that a class can implement more than one interface but extend only one class. The class that implements the interface should implement all its members. Like an abstract class, an interface cannot be instantiated. Should I use an abstract class or an interface? Abstract classes provide you the flexibility to have certain concrete methods and some other methods that the derived classes should implement. By contrast, if you use interfaces, you would need to implement all the methods in the class that extends the interface. An abstract class is a good choice if you have plans for future expansion, i.e., if a future expansion is likely in the class hierarchy. If you would like to provide support for future expansion when using interfaces, you'll need to extend the interface and create a new one. On a different note, it is easy to add a new interface to the hierarchy if need be. However, if you already have an abstract class in your hierarchy, you can't add another, i.e., you can add an abstract class only if none are available. You should use an interface if you want a contract on some behavior or functionality. You should not use an interface if you need to write the same code for the interface methods. In this case, you should use an abstract class, define the method once, and reuse it as needed. Do use interfaces to decouple your application's code from specific implementations of it, or to restrict access to members of a certain type. By using interfaces, you can, for example, include behavior from multiple sources in a class. That capability is important in C# because the language doesn't support multiple inheritance of classes. In addition, you must use an interface if you want to simulate inheritance for structs, because they can't actually inherit from another struct or class. Implicit and explicit interface implementations. Interfaces can be implemented implicitly or explicitly. Let me explain how these two implementations differ. Consider an interface called iBusinessLogic.
So this is the keyword of interface. So this is not a class or method, it is an interface, and it has one void method which is initialized, name it as initialize. Then we define the real class which implements the logic interface, iBusinessLogic, and we define the method as well. So in this case, this is explicit method call, and this is implicit method call. I see. So this is being like a constructor, I think. Okay, so let's try to get some more information. Okay, so this compares their differences between abstract and interface.
We cannot create an instance of this class. Interface can be only variable type and not instance. It can have constructor. It cannot have constructor. It can be derived to some other class. It is created to be derived by other class. It can have implementation non-abstract of one or more methods. It cannot have function definition. Concrete class can implement only one abstract class. Concrete class can implement many interfaces.
I think this is one of the main differences.
It can or cannot contain the abstract methods. It should only have the method signatures. It can have private, protected, internal data members. All the members are public by default.
Oh, this is also another difference.
It cannot be derived to a structure. It can be derived by a structure.
Okay, so let's look for practical implementation.
Practical implementation of abstract class. Let's talk about the practical implementation of the abstract class. Most people are very much aware about the theory of these classes, but as far as implementation is concerned, they are not sure about it.
Okay, so first I am going to copy and paste the abstract class. So the abstract class is public. It has abstract keyword. It is named as data source. So it has data source name and private string environment. So it has protected data source method. So you see, this is not an abstract method. This is a real method, concrete method. It takes environment and string variables. So it assigns this environment and this data source name, which are these. You see, when I double click them, it automatically highlights which are these variables to the new incoming environment and name. So then it calls another real method, which is private. So protected means that the derived classes will be able to also use it as long as they are in the same assembly. And get data source credentials, it will console write. Let's make this as message box show, because we have made it a VPF. And there is public abstract void open and return connection string. So this is an abstract method inside it. Okay, so let's add a button and go step by step to understand the usefulness and implementation of abstract and interface. Okay, let's name this. Okay, so can I use it like this? No, because it is an abstract class, therefore you cannot create instance of an abstract class. This is not a concrete class. So I have to write another class which will be derived from data source class, which will be the children of a data source class. So the first other class we are going to write is MS SQL data source, which implements the data source as the abstract class. You see, this MS SQL data source has a public constructor which takes a string, and the base is environment MS SQL. So the base means that it is the constructor of the inherited class. Okay, so this is the constructor of data source, and this is the constructor of MS SQL data source. So you see, it takes environment and it sends the constructor of the base class, the inherited class, as the environment and MS SQL, this one. So MS SQL being this one and environment is being this one. Okay, and it has a method which overrides the open and return connection abstract method. It is like this. Let's change it as well. And then there is another public class which inherits data source. This time it is inheriting the data source like this. It has also another constructor which initialize the base class like this. You see, they are empty inside in the scope. You can also do something here if you want. And let's make that something. Show the constructor of MS SQL class executed. Okay, let's make it like this, and let's do the same for the Oracle data source. And this also overrides the open return connection. Okay, now I can define MS SQL data source and Oracle data source like this. You see, it is requiring me to set the environment, and environment will be displayed as here. Okay, let's set the environment as okay, and let's make this as Oracle. Okay, now I can call the method they have like this. It doesn't take any parameters, and okay, so let's run the application. So this is what is about an abstract class. Okay, I will also test something else after we run this. Okay, let's try it. So it says get MS SQL connection setting for MS SQL environment from config file. So this is the message that is printed by the data source. Did we call it? Okay, it is called where? It is called in the constructor of the data source, the abstract class. Okay, you see it is called at the constructor. Then our other constructor, which one this is being called. The constructor MS SQL data source executed. Then it executes the Oracle connection constructor, and the other constructors are executed, and then these are executed. Okay, so can I set something like this? And let's call this as MySQL data source, and I will remove this and remove this as well. Okay, so now it is telling me that the MySQL data source does not implement inherited abstract member open and return connection. So it forces me to declare this abstract method. I cannot bypass it. Therefore, I am going to declare it as void like this. Okay, then it also tells me that there is no argument given that corresponds to required formal parameter environment of data source string. So it also forces me to have a constructor like this. So this is the default constructor of MySQL data source. However, it is still not sufficient. I have to provide base, and like this, 1 and 2. Okay, so you see, you have to define all the abstract methods and classes inside abstract class. I can also set here another abstract class like this. GG. Okay. Now it will ask me. Oh, it doesn't ask me to also define the abstract class. Okay. So I have to only define the methods, abstract methods inside the inherited abstract class. So the classes, the abstract classes inside abstract class, you don't have to overwrite it. Okay, this is a difference, a key point, perhaps we can say. Yeah, it is working. Can I make something like this? Okay, I also don't have to overwrite non-abstract methods as well. And if I had something like this, let's say public data source. So this will be a default constructor. Yeah, it is working. So now that I have default constructor, can I define something like this? And I will remove this. Yes. Now I don't have to define a constructor like this because by default it will use the default constructor, this one, of abstract class data source. Okay. I just want to be sure that I am using the correct term, method overloading. Yes. Yes, this is correct term. Okay, this is constructor overloading. This is default constructor. And okay. Okay, this one overrides, or let's say this one defines the over constructor of base class. Okay, and this is also, this one uses the default constructor of base class. Okay. Okay, I think everything about abstract classes should be understood by now. Now we will see the interfaces. And this was a good example. Let's continue what else they have written. Conclusion. Okay, let's see the article of interface written by Vikram Chaudhary, which is an experienced developer. Okay, yeah, it has he has so many views, pluses, and such. Okay, why do we use interface? Okay, I will take a pause for a moment. Okay, let's continue with interface.
Why do we use C# interface? In this article, one would not cover anything about C# interface. I have already covered about existence of interface in C# and what are interfaces. As soon as we learn about C# interface, we think that it was very easy to understand about the interface, and now at least I have understood a very important concept of C#. But there are different sets of concepts which makes interface so useful. Let's understand them.
Okay, so I'm reading right now, and whether this is to understand, to evaluate whether this is a good example or not. Okay, yes, this wasn't a good example. So let's check this one. Okay, I think this is a pretty straightforward.
Another way to achieve abstraction in C# is with interfaces. An interface is a completely abstract class, which can only contain abstract methods and properties with empty bodies. It is considered good practice to start with the letter I at the beginning of an interface, as it makes it easier for yourself and others to remember that it is an interface and not a class. By default, members of an interface are abstract and public. Note, interfaces can contain properties and methods, but not fields.
Okay, so we can set properties and methods, but not fields. Okay, so what were the field and properties? Okay, for example, this is a field. Okay, so we can set public fields as well. So you see, I can even set public field. However, this is not the case for interfaces. So let's implement the interface here. Oh, I think multiple interface is a better example. Yeah, let's do it. Okay. So first we have the first interface like this. You see, I will not be able to uh, set a field here such as by the way, you see there is no accessibility member definition. I mean, there is no public, protected, or private because by default they are all public, and by default they are all abstract. So you see, it doesn't allow me to contain instance field. It includes field. Can I set something like prop sr? So this is a property, and yes, it allows me to set a property, and this is a method. So this is the second interface, and let's put here something else. Price. And you see, now I can compose a solid class which implements two interfaces. Now I am getting error. Do you know why? Because main window dot demo class does not implement interface member main window of iFirst interface SR good code. So I have to implement it, and if I write it like this, will it work, do you think? No, because it is expecting from me to define a property, not field. So what I need to do is something like this, and by default this will be null. And you see it is telling me that I need to define the other property, and it will be money price. Can I set it like this? No, it is expecting the same variable name. Also, can I set this? I think I wonder if private. Yok, no. It is requesting to be public, maybe protected. It doesn't work here. Can we set this as protected? Okay, this is weird because we have set it protected here. I define protected like this. Maybe it will get fixed. No, so it has to be public. Okay, so this is another difference of interface. Okay, therefore this will be public. If I remove them, I wonder if it will be by default public. No, by default still private. Okay, now works. And so this method, let's make it equal to good code. Okay, I will do something else. I will try. So can I set a constructor? Okay. Okay, it says interfaces cannot contain instance constructors. Okay, so interface cannot have a constructor. Interface cannot be static as well, like this. Okay, you see the modifier static is not valid for this item. It is not valid for abstract as well. Oh, it is what? Let's try it. Abstract class. Okay, abstract class cannot be sealed or static. Okay, so both is not work valid. Okay, and interface cannot have constructors. Okay, classes. Let's make sure that it is true. So I am going to define another abstract class. Let's test it. Always version 2, and let's see if I can implement it as well. Okay, it says that does not implement inherited abstract member. Okay, so it is not working. However, we use the comma. This is the correct sequence. Okay, cannot have multiple base classes. However, can we implement abstract and interface at the same time? Let's try that as well. Test class, and I will make it implementing data source and second interface. Okay, let's test it. Okay, this looks like it will work. Let's check it out. So let's copy and paste this for now, and let's add these two, and we also need these as well. Okay, it appears that you can have one base class and as many as interfaces you want. Okay, like this. Yes, it is working. So you see, it may be really useful in such scenarios in your programming. So this is how interface and abstract class and base class works. Okay, so you get the idea. We cannot define multiple base classes. It can only inherit one base class. Uh, Interfaces. All right. Okay, so let's take our notes here. Okay. Okay. I wonder if the solid class is a correct terminology. Concrete class, okay, not solid. Okay, let's change it as concrete class. So this is the correct terminology, and where we have written, okay, we have fixed the terminology as well. Okay, so we have seen the abstract, and okay, so dynamic polymorphism example. I think it was somewhere here. Yeah, here.
Polymorphism and overriding methods.
Okay.
Polymorphism means many forms, and it occurs when we have many classes that are related to each other by inheritance. Like we specified in the previous chapter, inheritance lets us inherit fields and methods from another class. Polymorphism uses those methods to perform different tasks. This allows us to perform a single action in different ways. For example, think of a base class called animal that has a method called animal sound. Derived classes of animals could be pigs, cats, dogs, birds, and they also have their own implementation of an animal sound, the pig oinks, and the cat meows, etc.
Okay, so let's so this is basically inheritance. So inheritance and polymorphism are, I think, same. I wonder if there is any difference.
Polymorphism and inheritance are pivotal, need to be ingrained and fundamental concepts to C# and object-oriented programming. Saying you know C# and not this is like knowing how to speak English and have no concept of what the alphabet is. Sorry to be blunt, but it is true.
This is polymorphism and this is inheritance. Okay, so in the polymorphism, they have the same variable names. However, they do different tasks, and in the inheritance, okay, they have oh, I see. So this is inheritance, okay, and let's add a class to explain it better. How it is written, polymorphism. Okay, so inheritance versus polymorphism, let's add it as public. Okay, so this is inheritance example. And there can be even a class like this, let's say subclass and level 2 subclass, and it can be message of level 2 class like this, and we can have so this is multi-level classes. The level 2 subclass also contains public or protected fields of the derived base classes, parent classes. These dot okay. Okay, so here I am not able to modify the inherited class fields, but I should be. What I mean is, so let's define another one. Class, okay, you see I am able to access all of the variables. Maybe I can access it inside constructor. Access them inside constructor. So this is the constructor of the level 2 class, and here these dots, yeah, I can access them. Arbitrary message, let's say arbitrary message of level 2 class, and okay, hello message of level 2 class and message of level 2 class. Okay, so we can print each of them as we want. Okay, and let's make this as yeah, this should work. So I will compose example of each class, base class example equal to like this, and new base class. Okay, so let's print each of them, or let's return a list, and I will show that list as I want. Okay, return new list, and inside here I will return the messages like this. Okay, then okay, it will be like this. Okay, arbitrary message of level 1 class, and hello message of level 1 class, and then we will have arbitrary message of level 2 class. Okay, we will change them like this, and hello message of level 2 class, and message of level 3 class or level 2 class. Okay, and it will return a new list. Okay, and let's add another button to test them. So what I'm going to do is I'm going to copy and paste this button. Okay, it is copied and pasted, and I will name it as BT and Polymorphism. Okay, versus inheritance. Okay, let's add a click event. Alright, so what I need to do is inside this click event, I will compose an instance of inheritance versus polymorphism. Why it doesn't appear here? My x class equal to, okay, and what I'm going to do is I will get the messages. Oh, currently I am not able to call this method. Why? Because it is inside the test class. Okay, so therefore I have to compose a test class actually. Equal to new. Okay, now it should work. Dot still I can't access it. I see, because it is static and not public. Okay, I can directly use that perhaps. Oh no, I can't use it. I need instance of the class. Testing. Oh, now I can access it like this. I don't need instance because it is already static. And I will add them to a list box so we can see how they are returning. And let's add these. Okay, I will take a pause. Okay, so let's resize our list box like this. Okay, let's name it as like this, and okay, so when I run it, we will see the multi-level inheritance. You can have as many as level inheritance, I think. Let's see what is the maximum level. No, this is not the one. No, that is not also the one. Looks like hundreds of, probably someone has got problem at 700, but hundreds of inheritance. Okay, so hello message of base class is hello world. Arbitrary message of level 1 class is hello world. Hello message of level 1 class is hello world. And arbitrary message of level 2 class is hello message of level 2 class. Hello message of level 2 class is hello message of level 2 class, and message of level 2 class is this one. So let's check our, you see we have failed to change some variables. That is why they were incorrect. So let's rerun the application. Okay, message of level 2, this one as expected, and other ones are also as expected. So now we will make polymorphism, which is different or somewhat different from inheritance. Okay, where is it? Okay, here the polymorphism. So in the polymorphism, let's put some separator. Okay, so in the polymorphism we use the same variable name from different classes that inherits the same base class or same interface in this case. So they are generated from same interface, and they use the same variable name. They have to use the same variable name because they are using the interface. That can be also abstract class, doesn't matter in this case, because this abstract property which has only get method, not set method. And so this is polymorphism. I am going to add it to the our method. So an animal object from animal class, which is, you see, define it as dog. Okay, so you see the left side is animal, which is the interface, and right side is the class generated from that interface. Here also same, left side is interface and right side is cat class. So these classes can, or these objects would have all the attributes of this interface. However, if they have some other public attributes such as this one, dog count, and let's make it as cat count, they wouldn't be available, I believe. Let's check it out. Okay, Doc message. Okay, so, or let's say doc name. And cat name. Okay, and let's see what other properties are available. Okay, you see only the name is available because this property is not available in say interface. Therefore, it would not be available in objects generated from interface. Okay. Same apply here. So enable dot it was doc. Okay. This is invalid because IR doc property is only available to doc base class. Okay. So this is polymorphism. All right. Okay. There can be better examples of polymorphism. Let's find example. Okay, same animal sound. They inherit the same base class. And you call them like this. Yeah. So this is polymorphism. Okay. Let's write it as well. Okay, so we will look at dynamic polymorphism. This was regular polymorphism. Let's take the node first here. Okay, and we have already written it, therefore I will just add this. Okay, and let's continue with the dynamic polymorphism.
The objective of this article is to understand the concept of C# polymorphism, which includes the concept of method overloading, operator overloading, and method overriding. In object-oriented programming, polymorphism means many forms. It is a Greek word poly which means many, and morphism means forms. In simple words, it gives the ability to a class to have multiple definitions for a function method with the same name, like same method name but different return type and different number of parameters. It is the pillar of object-oriented programming along with encapsulation and inheritance. Polymorphism is of two types: static polymorphism, dynamic polymorphism. The static polymorphism is often referred to as compile time or early binding polymorphism, whereas the dynamic polymorphism is referred to as run time or late binding polymorphism. The static polymorphism is achieved using method overloading and operator overloading, whereas the dynamic polymorphism is achieved using method overriding. Also, in the subsequent section of this post, you will find the implementation of operator overloading and the list of operators that can and can't be overloaded.
Okay, so classification of polymorphism is as below. There is polymorphism, and there is static polymorphism and dynamic polymorphism. The static polymorphism uses method overloading and operator overloading. Dynamic polymorphism uses method overriding. We will see each of them right now.
Static polymorphism, method overloading. This type of polymorphism is also referred to as compile time or early binding polymorphism because the decision about which method will be called is made at the compile time. Now let's see one example of method overloading where we will give two methods the same name but different signatures, number and type of parameters to achieve static polymorphism.
Okay, so this is the regular method overloading as we know, and it is called as static polymorphism. Let's add another class to make example of it. Okay, method overloading. Okay, and overloading, and I don't need this anymore. Okay, I will make them as static. Okay, so you see there are two methods and their signatures are like this. Okay, double plus double and double. The signature is double and double and string. So if I provide double and double, it will use this. If I provide double and string, it will use this. Let's make this something more reasonable. I will make it as integer, and I will also multiply this with extra multiplier like this. So it is pretty simple. Let's add a button to call it here. Okay, let's name it as okay, one moment, name method static polymorph. Okay, so the static polymorphism is method overloading basically. Can we make this as wrap text? Let's look such property exists or not. There is no. Let's find from somewhere else. Okay, it looks like we have to set the text as multi-line like this. Okay, so let's make it here. I think no, it doesn't work. So maybe from here text maybe here. Hmm. I am wondering if there is, I see there is button and text block. So inside the button, I will have text block property like this. It is harder to do. I see. But we are showing the example of how to do it, by the way. And now it should work. Yes, it is working as I wanted. Okay, and I will take a note. One moment. Okay. So we have done text wrapping, and I will just copy and paste this button so it will be easier to use further ones. Okay, let's call it as this and change this text. Okay, let's delete the other button, which is this one. You see it is giving invalid markup because I have used the same name twice. And let's add another click event like this. Okay, so this will show basically the first method as like this. And I will call it as method overloading dot trueBank, and here's the double amount. Okay, one moment, I will change the name. Example. Okay, and example, and I will provide 20. One moment, it has overridden my okay. 20. Okay, you see, this is the first method overloading, one of two, double. To set a number as double, you can use this. However, in this case, it is automatically converting it is inherently understanding that it is double. And first method overloading call, and second method overloading call, or let's say static polymorphism. And I will add another number here with 20. So let's run the application. Okay, so it is correct. Okay, let's run. You see, first method overloading static polymorphism call with signature double plus double equal to 420, and the second method overloading called static polymorphism with signature double plus double 40,420. By the way, there is also integer at the end. You see, when I hover it, it says that double amount, double rate, and int I are extra multiplier. It understands that, and here it understands it as double amount, double rate. This is you were using all the time since you have started coding with C#. For example, this is everywhere, such as message box show. Let's see how many. You see this one, this show method has 12 method overloading. Okay, each one has different signature. For example, the signature of the last one is window and string and string and message box button and message box image and message box result and message box options. Okay, so if you provide this, it will go to this method overloading. If you provide as message, it will go to the first one. Okay, so this is static polymorphism. Okay, let's write it. Okay, I think this is a good explanation. So whenever you do a method overloading, it can be called as static polymorphism. By the way, this is compile time method overloading because the variable types are known before the application is compiled. Okay, so this is known as this is known to the compiler before you compile it. Therefore, this is static polymorphism. I will take a pause. So we have seen the static polymorphism. Now let's see dynamic polymorphism, which is method overriding.
Dynamic polymorphism, method overriding. This type of polymorphism also referred to as runtime or late binding polymorphism because of the decision about which method is to be called is made at runtime. In dynamic polymorphism, we override the base class method in derived class using inheritance, and this can be achieved using override and virtual keywords. Now we will see the example of method overriding where we will give the same method name and signature, same number of parameters and type but with different definitions, two in parent and child class.
Okay, so let's see the dynamic polymorphism example here. Okay, let's add another class. Or we can even make it like this. Okay. So let's make this as okay. Let's just don't change it. So here we have interest, which is like this. By the way, I don't like interest example. Let's change it to level 1 multiply or let's say base multiply, and let's call this as plus multiply, and I will call this as over multiply. Okay, so this will be like this. Okay, so now we have virtual method. I will call it as execute example. So every method has the same name. You see now they have the same signature. Signature is double plus double, and here it is double plus double, and here double plus double. So they have same signature. However, this time we are using a virtual keyword. So if I remove the override, it will tell me that hides inherited member. So make the current member override that implementation, add the override keyword. Otherwise, add the new keyword. Okay, so this is still working with inherently overriding, I think. However, this way we are overriding it. So okay, let's copy and paste the example. So this time we will use method overloading dot example. By the way, we don't I see, we should not make this as so we can make it static. It is fine. Equal to example. Okay, there was an error. Yeah, we don't have example. Okay, why we are having a problem? Because we are using the incorrect one. Okay, so this is base multiply. Base multiply. Okay, now this is more sense making. Okay, then from this base multiply we will use execute example, and let's message box show base multiply execute result equal to final amount. Then you see this was base multiply. Now I am going to make it a new class type object. It will be over multiply. Okay, and so this will be over multiply result. Okay, and finally it will be plus multiply. Okay, we will call it as plus multiply. So you see, when this line of code executed, it will be base multiply. When this one executed, it will be over multiply, because we have used override. If we don't use override, it will be different. What I mean is, let's test it as well. So how we are going to test it is, let's put another example. As I will make this simple. Amount plus rate and no override. Okay, and this is still virtual, and okay, I will remove the no override and plus 1000 and plus 1 million. Okay, so let's see how will it behave if we don't override. Okay. Let's call this as okay, so I will just copy and paste like this. It will be like this. Okay, and no override. So let's add some simpler numbers like 100, 100. Okay, and this time base multiply, no override. Okay, so let's see the difference of override and no override. Okay, first, second. Okay, base multiply execute result is 5500. Why? Because it multiply them and it makes what we were giving here is it makes 500, then we plus it with the amount which is 5000 plus 500, and then we sum it with 1000, so it should be 6500. However, it is not that way. Oh, okay, because we have to check this. Yes, it is correct. And then the overrided method, override multiply, which is here. Okay, so let's calculate it with the calculator to see. Amount is 5000 plus rate 01 500. Sorry. Then we multiply it with 1005 and we sum it with 5000. Okay, so same, and other one is this. Okay, so now we are going to check the no override. So base multiply no override here 200 as expected, then it is 200 again. So you see, since I don't use no override, it is not effective. Still, the no override of base method is used. Why? Because they are defined as base method. However, if I make it like that, let me show you. Var base multiply 2, and this will be over multiply version 2 no override, and base multiply 3, this will be plus multiply, and I will call it as plus multiply version 2. So let's check. If I define new objects like this and this, they should be effective, I believe. Let's check that too. Okay, 200, 200, 200. Okay, version 2 still 200 and version 2 still 200. Okay, so if you don't overwrite, it will be, let's say, hidden by the base class. Okay, so this is hidden and therefore we cannot use it. Okay, how we can use it? I think we can use it like, let's try this. New override, and I will add +2, I mean multiply 2. Okay, and then it says use either new keyword. Okay, and new keyword. This will be, okay, this is plus multiply and this is over multiply. Let's multiply with 10. Okay, so this time I think we should be able to get some different results. So let's do it again. This time I will use new override keyword, and this will be 4. I don't need to define it like this anymore because they will be same. And new override and new override. Okay, so let's see with the new keyword. I think this time it will work. If it doesn't work, then we have to use override. I think override and new is same, but I am not sure. Okay, no override base is, okay, no, okay, new override is 400, new override to 400, and new override to 400. Okay, so the new keyword is still same. Because I am using still the base multiply. This is wrong. Yes, I have to use this and this one, and here I have to use this and this one. Okay, you see we had made error. So now let's compare again. Okay, or multiply. Oh, this time it is working. No override. No override. Okay, yes. Yes. Oh, this one was different. Why? Mm, It should be 4,000. Interesting. 2,400. 2004. Oh, because this is 400 and this is 400. Okay, this has one reference and this has one reference. 2,400. Okay, correct. Correct. And this is 200. Let's check it out. Plus multiply true, over multiply true. Okay, I think here we have an okay. Yes, it seems like both is working. So we have written incorrectly here. If you don't override and leave it like this, it will automatically hide the base class method. Therefore, this will be valid. Okay. So it is implicitly overriding, basically. Override versus new keyword. I see. The override keyword is used to extend or modify a virtual abstract method, property indexer, or event-based class into the derived class. The new keyword is used to hide method, property, or event class-based class into the derived class. What is the difference? Okay, someone has already asked that. Inherited class. So if you define with nib, it hides this one, and we should. Okay, someone has asked it. Okay, so let's try to understand. Okay, so now we have base class and we have virtual do it. Then we have derived class and we use override. So when we use base b equal new derived here, and we call do it, it calls derived do it. Okay, it calls overridden one. And here we have base and virtual. Now we use new keyword and we define with new derived and we call with new derived. So B calls base do it here, and D calls derived do it. Okay, I see. So this is the difference. Okay, this is the difference between base and new. So okay, so if we use, yeah, we shouldn't be define it like this. We should have defined it like this. So when we define it like this, okay, I think it will make more sense of no override and override difference, new difference. Okay. I think now it will be more sense making. New override, new override, and new override. Okay, so the base multiply is from let's delete this because it seems like we base multiply is from base multiply type, and each time we redefine it. However, the base multiply still stays same. So maybe we should, okay, I think you should understand this. So we call the no override method and plus multiply and over multiply. Okay, so now we will be able to see the difference when we don't use no override and no new keyword. It will be displaying as the base method. Okay, because they are from the base type. I think it is pretty clear now. So no override 200, no override 200, and no override 200. Why? Because they are defined from the base class. Okay, and new override shows the still showing the base method. Oh, this is interesting. Okay, say no. Okay, new override here. No override here. Okay. So if you don't override, everything is displayed as the base class. Okay, yeah, it is that way. Only overriding overrides the base class. So multiply, execute. Okay, no override 200, no override 200, no override 200, new override 400, new override. Okay, yes. So this didn't work. However, if we make it like this, let's name. Let's add some more description. Then I will make it like this. Let me show you. This time it will be from this. I think this will give error because we can't redefine it. And okay, we don't need to show the base anymore. Okay, and over multiply from over multiply class. And here we will have from base multiply class version 2. Let's call this like this, and this like this, and okay. So now we will try with no override method from their type. Okay, not from base type. And let's see if it makes difference. Base type is no effect, and new override 400, new override 400, new override 400. Okay, so over multiply from over multiply new type. Okay, it works, and it works. Okay, so basically new keyword and no new keyword is same, I think. Yeah. I see. However, if we don't make this one as not virtual, I think it will throw error because we don't use the new keyword, or it won't. I see. Okay. Okay, so I get the idea now. Okay, now I am going to write the correct definition. And if it is not virtual, can we override it? Probably no. I will try to override. Yes, cannot override inherited member. Okay, now it makes the sense. Okay, so let's write some description. A method in a derived class. Okay, method or member diyelim. Let's say member, it is better. And if you don't use override keyword, it inherently hides the base class method. And if you use new keyword, it explicitly hides the base class method. Okay, so hiding can be done. Hiding of base class members can be done both on virtual and non-virtual members. Okay, I think this is the correct definition, and a good example is here. Okay, and a good example of new here. Okay, I think it should be very clear to you right now. If it is not, please make tests yourself. You will understand it. Okay, let's say yours. Okay. Numbers and hiding. Okay, so what else there is? Dynamic polymorphism, yes. Multi-level inheritance, yes, we have shown multi-level inheritance. So what is the multi-level inheritance? I think it was here or somewhere else. So this would be a multi-level inheritance. Let me show you. Lion from cat, and let's add by the way, it would expect me. Oh, it doesn't expect. Okay, let's say hunger multi-level inheritance. Okay, and we have shown that as well. We have shown these two, method overriding. Okay, these will remain, and Okay. I think this is enough for today. And oh, one more thing. So about comments to the videos for lecture attendance, I am going to make an addition to your project details. Let me show you. So here, okay, this is the number 15. Okay, here. So everyone will be sending a Word or PDF document along with their final project files. This document will contain screenshots of your all comments to the lecture videos. Okay, let's fix this as well. Of your all comments. Okay, and take screenshots with high resolution. Your comments has to be clearly readable because I will read your comments from that file. Those who fail to send this document will be counted as not attended to the courses, or let's say lectures. Therefore, they will get FF. So this is really important. I will check your comments and I will see how did you make your comment. Was it good or not? Did you watch the did you properly watch that lecture or not? So this is really important. Let's update this as well. Okay. So please watch videos and make good and unique comments to them. This is really important. Okay, so comments are mandatory for you to pass this course with success. Okay, it is not like you are not going to attend the lectures due to remote education. With command system, you will be I will be sure that you have watched the lectures and attended the course. Okay. Also, please try to be careful and not get coronavirus because coronavirus is really serious disease. Don't take it lightly. My grandfather has passed away from coronavirus very recently. So please try to stay at home and let's upload our project file to our GitHub repository. Okay, end of lecture. Hopefully see you next week.